Okay, so let's do the energy part of problem 12.26. I set it up actually before the video, but we're going to use equation 12.2 on page 305 for the energy. What's the final energy of the atom? I think a better question is what's the final energy of the electron? In this, it's equivalent, of course, in this question. So what I did was I looked up all these variables and wrote them down here, so you didn't have to wait for me to do that. But this is the mass of the electron, which is 9.11 times 10 to the negative 31 grams. This is the charge of the electron. Careful, that's not the base of the natural log. It's the charge of the electron, which is 1.602 times 10 to the negative 19 coulombs. That's just 8, of course. That's the permittivity of free space, 8.854 times 10 to the negative 12 coulomb squared per joule meter. This is Planck's constant, which you've seen before. Now, by the way, if you put in the base of the natural log here, it wouldn't work because you would end up, the units wouldn't cancel. So I think the last thing I'll do maybe is prove to myself, which I would do in a quiz or exam, prove to myself that the units all cancel and everything makes sense. Okay, so first of all, let's just say, well, let's just plug these numbers in. 9.11 times 10 to the negative 31 kilograms. 1.602 times 10 to the negative 19 coulombs raised to the fourth. 8.854 times 10 to the negative 12 coulomb squared per joules meters, and 6.626 times 10 to the negative 34 joule seconds. And that's n squared. We're talking about now in this system, it's a ground state, so it's 1 squared. So that's equal to 1. Okay, let's calculate this out. 9.11 e minus 31, enter. 1.602 19, enter, raised to the fourth. Be real careful here. My calculator will do this. It takes me, basically my numerator comes 6.00 and a few more zeros times 10 to the 106, or negative 106. So if your calculator might handle this, you may have to deal with the exponents or the degrees of magnitude in a separate calculation. Just make sure your calculator will do this. 8, enter, 8.854 times 10 to the minus 12. Is that right? And that's, oops, this is all squared. Oops, whoa. That's squared, and this is squared. Okay, enter. 6.626 e minus 34, enter. Times. So this ends up being 2.753 times 10 to the minus 88. It's going to end up being, let's see, joules total. Okay, but we'll prove that ourselves in just a minute. And I'm going to go ahead and divide these now. This is equal to 2.179 times 10 to the negative 18 joules. Okay, careful. Minus, that's a minus, right? None of these were negatives. So it's really minus. Okay, that's the energy of the electron. Now let's prove it to ourselves real quickly, since this is such a short video. Let's take this equation, and I'm going to bring it down here. An electron, what's the mass of an electron? What are the units of the mass of an electron? Kilograms. What are the units of that? Coulombs raised to the fourth. What are the units of 8? That's dimensionless. Units of the permittivity of free space is coulombs squared over joule meters squared. Planck's constant is joule seconds squared, and n is also dimensionless. Okay, so this needs to be an energy when I'm done. This becomes kilograms, coulombs to the fourth. Here's coulombs to the fourth again. Here's joule squared, meter squared. I'm going to take those all the way up. So the denominator and the denominator, I'm going to take those all the way up to the top. Joule squared, meter squared. Okay. Joule squared, second squared. Okay, can you see that the coulombs cancel out, the joules cancel out, and we're left with kilograms meters squared per second squared, which is the definition of it. That is the definition of a unit. But I'm gonna still think about the dimensions of this. That looks like a mass. Wait. Yeah. Mass, and that's a velocity squared. Perfect. This fits very nicely into this equation, which is in my soul. mv squared. I can see it's unitless. The units are the same. So I'm very happy with the fact that this is indeed joules. That's because that's right. That's how we got joules from that. So if our units in the end are kilograms meters squared per second squared, that's the definition of a joule, and we're good. Okay, that's helpful.